In this video, we will talk about how to find values using normal distribution. The objectives: how to find a z-score given the area under the normal curve, how to transform a z-score to an x value, how to find a specific data value of a normal distribution given the probability. So in the previous section, we were given a normally distributed random variable x and we were asked to find the probability. So now we're going to go backwards. We will be given a probability and we will be asked to find the value of the random variable x. So in this particular problem, it tells us to find the z-score that corresponds to a cumulative area of 0.3632. So I already have the answer up here. So I'm going to show you how to do this using the z-table. So this is the answer here. If I can get to it, there we go. This is the answer here. So if you wanted to use the z-table, what you would do is you would look for 0.3632 in the body of the table. So this is we were given this area. We want to figure out the z-value that corresponds to this area. So you would look up 0.3632 in the body of the table, and here it is right here. So to figure out the corresponding z-score, you'll go over here to the left. Oops, I can't draw. You get negative 0.3, and then you go up to get 5. So the z-score is negative 0.35. Let's look at another one. Let's find the z-score that has a 10.75% of the distribution's area to its right. So they gave you the area to the right. I already have the answer up here is 1.24. But how did I get that? Well, the z-table only gives you the area to the left of the z-score. So this is the area given with the table. So to figure out what this area here is, you're going to take 0.1075, subtract it from 1, and you get 0.8925. So you're going to have to look up 0.8925 in the body of the table, and here it is right here. To figure out the z-score, you go over to the left, you get 1.2, then you go up and you get 4. So the answer is 1.24. So I'm sure you're asking, well, I don't want to use the table. How do I use technology? Well, I will show you how to use StatCrunch to figure out these problems. So we're going to go to Stat, Calculators, and we want to go to Normal. And we were looking for z-scores. So our z-score, we always know that the mean is 0 and the standard deviation is 1. So that's what you're going to plug in here. And for the first problem that we did, we wanted to know the area to the left. We knew the area to the left is 0.3632. We wanted to figure out the corresponding z-score. So what you would do is you have the probability that x is less than. I'm going to take this 0 out. I'm going to delete this out. And I know that the area left to whatever the z-score is 0.3632. Okay. Once I hit compute, this blank box will fill in with the answer. So when I hit compute, I get negative 0.3499, or you can just round it, negative 0.35. And as you can see, the visual comes up. Okay. So that's the answer that we got, negative 0.35. If we wanted to do this next problem, we don't even have to figure out the area to the left. We can just go ahead and use technology and just plug in the numbers. I know that the area to the right of the z value is 0.1075. So when I go to StatCrunch, I'm going to change this less than to greater than. And I know that the area to the left is 0.1075. So I'm going to make this box here blank. I'm just going to take that out. And I want this area to be 0.1075. And I hit compute, and I get 1.239 or 1.24. And as you can see, the graph comes up, you see the visual, and that's the same area that we shaded before. Okay, so once again, you don't have to subtract to get the area to the left and all that. You have this less than and greater than thing, inequality symbols. With the table, if you're going to use the table only gives you the area to the left, not the area to the right. Okay. All right, and this next one we're going to find a z-score given a percentile. So we have, I'll go back up, P5. So they want to know the z-score that corresponds to a percentile 5. So the z-score that corresponds to the area of 0.05. So when you see this 5, it's like saying 5%. So 5% is 0.05. So we want the area to the left to be 0.05. We want to figure out the corresponding z-score. So I already got the answer here. Let's go ahead and use StatCrunch. I'm not going to use the table with this. If you wish to use the table, you can. So let's go back here. Once again, the mean is 0, standard deviation is 1. I'm going to delete this out. I'm going to make this inequality less than, and we want 0.05. When I hit compute, I get negative 1.644. So based off the answer, we got negative 1.645. So we know it's halfway between those two numbers, negative 1.64 and negative 1.65. Okay. Let's do percentile 50. So this time we want the area to the left to be 0.05. Okay, so you really don't have to use the calculator for this, but I'll show you how to do it. You just have to think logically. The graph of a normal curve, the area underneath is 1. So if you split it in half, one side is 0.5, the other side is 0.5. With a normal distributed curve, that's a standard normal distribution, the mean is 0. So the z-score that corresponds to the area to the left, that's 0.5, is just 0, because it just splits it right in half. So I'll go ahead and put it in the table. I want this to be 0.5, and I hit compute, and as you can see, we get 0 in the box and we get the same visual. Okay, let's do one more. This time we want P90. We want the area to the left of the z-value to be 0.9. Okay, so go ahead. I'm going to put 0.9 here, hit compute. I get 1.28. And that's what we got here, 1.28. Now when you use the table, you may not get to exactly 0.9. You want to get close to the area as possible without going over. And the closest you can get with the table is 0.8997. That's in the body of the table. But once again, that's if you wish to use the table. I like using technology. So now in this next part, we're going to talk about how to transform a z-score to an x value. So to do that, we're going to use this formula. X is equal to the mean plus z times the standard deviation. So a veterinarian records the weights of cats treated at a clinic. The weights are normally distributed with a mean of 9 pounds and a standard deviation of 2 pounds. We're going to find the weights X corresponding to each z-score and interpret the results. Okay, so we got a z-score of 1.96. I'm going to use the formula mean plus z times the standard deviation. So they told us that the mean is 9 and the standard deviation is 2. So to figure out the z-score, the x value that corresponds with a z-score of 1.96, I just plug all these numbers back in. 9 plus 1.96 times 2. I get 12.92 pounds. So that's my x value. We want to find the x value that corresponds to a z-score of negative 0.44. I plug everything in. I get 8.12. The last one, we have a z-score of 0. What's the corresponding x value? You can take 9 plus 1.96 times 0. You get 9. In this next problem, it says scores for the California Peace Officer Standards and Training Tests are normally distributed with a mean of 50 and a standard deviation of 10. An agency will only hire applicants with scores in the top 10%. What is the lowest score you can earn and still be eligible to be hired by the agency? Okay. So we're going to go ahead and use StatCrunch to do this. They told us the mean is 50 and the standard deviation is 10. Okay. So before, when we did the other problems, we were looking for z-scores. So we knew that the mean was 0 and the standard deviation is 1. In this case, this is different, but we can still use StatCrunch to do it. We have different means and different standard deviations. So here's the visual. We want the area to the right of the x value to be 10% or 0.10. So in this problem, I kind of gave you the visual for a z-score. So you really don't have to do all that. And I left the information on here on how to do it with the z-score and the table and all that. I put this on the slide, but I'm just going to go ahead and use technology. So we got the mean of 50 and a standard deviation of 0. We want the area to the right to be 0.1. Okay, so look how I have it set up. Mean is 50, standard deviation is 10. We want x to be greater than or equal to whatever value such that the area to the right is 0.1. When I hit compute, I get my answer, 62.81. Okay, so if we go down, so the lowest score you can earn and still be eligible to be hired by the agency is 63. I just rounded. Now I think it says 62.8 here, and ours is, okay, it's the same answer, 62.8, so 63. Okay, let's look at another one. In a randomly selected sample of women ages 20 to 34, the mean total cholesterol level is 179 milligrams per deciliter with a standard deviation of 38.9 milligrams per deciliter. Assume that the total cholesterol levels are normally distributed. Find the highest total cholesterol level a woman in this 20 to 34 age group can have and still be in the bottom 1%. 1%. So they gave us the information. They told us that the mean is 179 and the standard deviation is 38.9. We want to look at the lowest 1%. We want to figure out what cholesterol level do you have to be at to be in the lowest 1%. Okay, so I left the information up here if you wish to do it with the z-table, but I'm going to go ahead and use technology. So I have 179 and then the standard deviation of 38.9. We want the area to the left to be 0.01. And I hit compute, I get 88.5. As you can see, the visual comes up, and it's the same visual that we have here. Now, as you can see, it's a little different. This says 88.363, and ours says 88.5. So it could be some type of rounding error, with StatCrunch and going with the table, but you're still in the ballpark. Okay? So what I would suggest when you do problems like this, always write out or draw the graph so you can have the visual so you'll know what area you're going to look at. And that way, that'll help you figure out whether or not you need to use less than or equal to or greater than or equal to. That's the end of this video.